Test days, the best days. Test days have to be the best days. And how do you do that? You prepare. All right? You focus. You do the difficult things. You make sacrifices. Let's go. All right. Pep talk over. Let's get to work. Okay. It says we have an expression here, and it says to simplify the expression. All right. So it is a lot easier than you might think at first glance. All right. Just like if I had 3D plus 2D, you'd see two like terms, and you'd add up 3 plus 2 is 5D, right? So in this case, same thing. You have two like terms, so you're just adding 1 plus 0.061, point plus 1D plus 0.06D gives you 1.06D, because 1 plus 6 hundredths is 1 and 6 hundredths. All right? Now this one, okay, we have that expression. We have 1t, because we slide a 1 in there if it doesn't have a coefficient, minus 0.2t. Well, that's just 1 whole minus 2 tenths of a t, so that's going to give us 0.8t. All right? Okay, now we're moving on to the next problem. And all we have is we have terms, and we're only going to combine the like terms. That means the ones with the same variables. Or if they don't have a variable, then they go together as well. So if they're constant terms, that's the terms without the variables. Okay, we do it in alphabetical order, so we'll start with the A terms. Okay, 4a and a minus 5a combines to be negative 1a. So that's so we get negative 1a, which we can write as just negative a, because anytime there's a 1, we can leave it out. All right, and then we'll do the c's. So that's these. I give it 2 lines to show that they go together. That's a plus 7c and a plus 2c, so that becomes plus 9c. And then this, I'll give this one 3 lines. It's all by itself. We just can bring that along for the ride, and we get our answer here. All right, now, number 4. Still going now. When we box out the terms, we stop a term every time we get to a subtraction or addition sign, right? So if I keep this term, I stop it, I cut it off right here. I only need 3 sides of this rectangle because my 4th side is already made for me. All right, box. I like to see those terms like that, and now I combine the like ones. I start with the variable terms, the ones with the variable, and I do alphabetical, so x before y. So I do my x's first. It's a minus 7x and a minus 3x, so that would combine to make a minus 10x, or a negative 10x. Then 2 lines here, 2 lines here. That's plus 2y plus 2y, so that makes plus 4y. And then I have 2 constant terms. I have an 8. I'll give that 3 lines. This 3 lines, that's going to give me, simplifies to 8 plus 3 is plus 11. All right, so which one is that? That's going to give me right there. Next one. All right, box out those terms. Just three little quick lines to make all those terms. And P comes before Q in the alphabet, so I'll start with my P's. 12P minus 8P is 4P. All right, I got 2 lines for my Q's. That's a plus 3Q minus 5Q. They're different signs, so I subtract. And then I keep the sign of the one that's more powerful, the stronger one, that's minus, right? It's simpler. So if I went right 3, then left 5, what's a simpler way to do that? Well, I could have just gone left 2 and ended up in the same spot. And then this minus 5 gets 3 lines. It's all by itself. It doesn't get combined with anything because it doesn't match any of the other terms. So looks like we got a third one here. All right, keep it going. We're cruising now. All right, now we got fractions. Wonderful. We are combining these like terms using our addition rules. Same signs add and keep, different signs subtract. We know when we add fractions, we need common denominators. So I'm going to underline the terms with the x's. That means I'm going to go 1/5 x plus 3/10 x. I need a common denominator. So 5 and 10 both go into 10. This one just stays. For this one, I have to multiply 5 by 2, so I have to also do the top by 2. There we go, 2/10 x. So 2/10 x plus 3/10 x gives us 5/10 x, which equals 1/2 x. All right, so that's our first part. Now we got, all right, this can be a little tricky, but we have -4/7 minus 1/14. We need common denominators. 7 and 14 both go into 14. Okay, this one can stay the same, but this times 2 and this times 2 to get to the denominator of 14. And now we get confused sometimes because we think minus here. So 8 minus 1 would be 7, but that wouldn't be accurate because what we have here is that is a loss of 8/14, and this is a loss of 1/14. So we're simplifying that to get a combined loss of 9/14, right? So they're the same direction or same signs. So we're going to add and keep that direction, right? If I said go left 8 and then keep going in that same direction one more, that would be 9/14. So we have this, so that's going to be 1/2 x minus 9/14. So that gives us the first one there. Okay? All right, almost on this first page. Let's box out our terms here. And we have like terms with the z's. So that's 3/8 z minus 3/4 z. I'm going to have common denominators. So that's going to be times 2 to get to 8. So times 2, 6z. And then we have our two terms now. They're different signs. So this is a positive 3/8, and this is a negative 6/8. All right, so they're different signs. We're going to subtract them. All right, so then it becomes 6 minus 3, which gives us 3. And we still have our 8s. Okay, so that's 3/8, but which one's more powerful of the negatives and positives? The negatives. Okay, so this guy wins out with the sign. All right, again, if you had 3 minus 6, okay, we learned at first, before we got to a little bit more like streamlined, we would say, okay, change subtraction to adding the opposite. Now you have 3 plus -6, right? Positive 3, 3 positives, 6 negatives. Positives cancel out the negatives, so you're left with -3, right? So that would equal -3. Okay, same thing. We have 3/8 and -6/8, so that simplifies down to -3/8 z. Okay, we can already see that this is going to be our answer, it looks like. But let's check ourselves by combining those like terms. So that would be 5/6 plus 2/3. We need common denominators. So 5/6 plus 3 goes into 6 times 2 times 2. So that's going to be 4/6. So together we get 9/6, which equals 1 3/6, which equals 1 1/2. Okay. So yep, you're right. It goes along with this guy here. So that's the right answer. All right, we're on to the next page. Woohoo! Let's go. All right, distributive property. This one you might want to star. If that number comes at the back end of the parentheses, you still have to go to the first term first. Okay, so we're multiplying. 3 times -4 is -12y. All right, 3 times, now I like to box these still to see that there's two terms inside the parentheses, and I circle this to show I'm multiplying it by the terms inside. So I'm doing 3 sets of -5z, which we would get -15z. All right, 3 sets of -5z would subtract 15z. I like to think of it like a positive times a negative gives me a negative. Right? We know positive times positive equals positive. Negative times negative equals negative. Positive times negative equals negative. And negative times positive equals negative. Okay, so, right? Kind of see it in two different groups. All right, and we've been talking about, you're like, is it subtracting or is it negative? And I just say, yep, because we're treating them very similarly, almost interchangeably. All right. So distributive number 9 is a little bit more simple, straightforward. We only have positive, so we're distributing that 4 to these two terms inside. So 4 times 3x would be 12x, and 4 times 4y, right, plus 4y. 4 sets of adding 4y would be adding 16y. Now this, check your signs, all right? I like to circle what we're distributing and box out the terms we're distributing to. All right, so we're doing a negative 2 times negative 3x. So up here, right, we see negative, oops, sorry guys. Switch that up. That's supposed to be positive. All right, a negative times a negative is a positive. So we distribute here. Negative times negative is positive 6x. And then this is a negative times a minus 2. See that minus there? All right, I treat it like a negative 2, though. Negative 2 times negative 2 is going to be positive 2, or plus. 2 times 2 is 4. Right? So negative times a negative is a positive 4. Okay? So we distribute that number out to the terms, and we treat minus signs like negatives. Okay? Keep it going. All right, we got, let's see, this table shows the side lengths of an isosceles triangle, and we want to write an expression for the perimeter of that triangle. All right, well, that means we're going to do perimeter means add up the rim. I like to circle the rim, make the T into a plus sign, right? I'm going to add up all the sides of the rim, and I have one side is 5x plus 3 plus 2. I'm going to add to that 3x minus 4. I'm going to add to that 3x minus 4 again. Isosceles, as you guys have been working on, has 2 equal sides. So we have 2 equal sides in that isosceles triangle. That doesn't really matter for solving the problem, but I guess you could do it a shorter way, but I'll stick to this. All right, so we're adding up all the sides. We got to find our like terms. All right. Okay, all of our x terms can go together. 5x plus 3x gives us 11x. And then we have a plus 2 and a minus 4. That gives us negative 2. Minus another 4 gives us negative 6. All right, so 11x minus 6. If you're struggling to figure out why it's minus 6, that's something that you're going to have to review with me or find another way to review and figure it out. Okay. Here we have another perimeter problem, but this time it's for a rectangle which has 4 sides. Notice they only gave you 2 of those sides, but we know that if you have the length on one side, that's going to be equal to the length on the other side. If you have the width on one side, that's going to be the same as the width on the other side. Okay, so then if we're looking for the perimeter, we're looking for adding up the whole rim. We don't just want this side and this side, okay? We also want to add in that side again and that side again. So we need 2 of each. All right, so we're going to be doing 2x minus 4 plus 3x plus 6 plus 2x minus 4 plus 3x plus 6. All right, another way to do it would be 2 sets of 2x minus 4 plus 2 sets of 3x plus 6. You could think of it like that. You could also add these up to start. 5x plus 2, and then double that because you need 2 sets of them. They're all going to get you the same answer. I think a lot of you will prefer this way because it just is a little bit simpler, more simple. Okay, so we are adding up all those sides. We combine our like terms. All right, that gives us 10x. And then we have these constant terms to put together. I guess we could do it this way. We could do the negative 4's would be negative 8 together, and the positive 6's would be 12. So 12 minus that 8 would be positive 4. Okay, and you can see if I distributed here and the other way, I'd get 10x plus 4 as well. Okay, so that's our answer there. Moving on. Now this problem should be slam dunk, but it's basically a memorization thing. Okay, it's linear or not linear. So we're looking at these 5 different expressions, and we're telling if they're linear or not linear. So it's not linear if ... 3 things could disqualify it. Okay, if a variable has an exponent. Okay, if we have a variable times another variable, or we have a variable in the denominator. Okay, that cancels it out from being linear. So if we go through them, we see, does this pass all three tests? Yes, so that's linear. Okay, does this pass all three tests? Yes, that's linear. Okay, does this pass all three tests? No, it fails number 2, right? Fails rule 2, so that's 7x, y. This, good, passes the test. This, which rule does that fail? That fails rule number 1, so that's 2x squared. All right? Now we're going down to a very similar problem. You should be able to get that now. So this passes all three tests, sorry. This passes all three tests. This one fails rule 2. This one passes all the tests, and this one fails rule 1. And there we have it. Okay. Now, we need an additive inverse. So that's the opposite of both terms. So that's a positive 2x, so it becomes negative 2x. Plus 5 becomes minus 5. All right, just the additive inverse, the opposite of both terms. So additive inverse of this would be negative x becomes positive x, minus 3 becomes plus 3. All right, moving on. Okay, we're cruising. All right, now, to get rid of parentheses, it's the first time we have these parentheses that we need to deal with. Okay, we're going to distribute, but we don't have anything to distribute now. So when there's nothing there, we'll put a 1 for both spots. All right, well, this first one can be distributed easily. 1 times 5, 5x. One set of plus 7 is still plus 7. Now, when we distribute this, we're actually distributing like a minus 1 to both, or a negative 1. So then negative 1 times a positive 3x becomes minus 3x. Negative 1 times plus 2 becomes minus 2. Okay, notice how the 3x turned to minus 3x and the plus 2 turned to minus 2. Notice the similarities between these, where we did the additive inverses and they changed their opposites. Well, that's what happens when you're subtracting here as well. You're subtracting that whole quantity. You're subtracting a 3x and you're subtracting a plus 2. So you can deal with it by distributing through multiplication a negative 1. All right? Then we got to simplify, so combine our like terms. And we have a 5x and a minus 3x, which simplifies to 2x. We've got a plus 2 and a plus 7 and a minus 2, which simplifies to plus 5. Okay, same thing for the next one. Put a 1 in front, distribute, I get 8x plus 9. Distribute, I get negative 6x. Distribute to the minus 2. This is where we're making a lot of mistakes. All right, we're distributing a negative 1 to a minus 2, and it becomes plus 2. Okay, like terms. Okay, 8x and a minus 6x is 2x. Plus 9 and a plus 2 becomes plus 11. Uh-oh, number 19, we got fractions. Okay, when we need to get rid of those parentheses first still, which is pretty simple. Distribute that. Doesn't change there, but because we're distributing a negative 1 here, they change their opposites. Right? Positive times a negative times a positive is a minus or negative. Negative times a negative becomes plus. Right? Now we have to find our like terms. Oops, messed that one up. Let's get rid of that one. Okay. Get these guys together. All right. Now I do some scratch work off the side. Minus 1/3. I need to find a number that both 5 and 3 go into. So that's 15 times 3 times 3 gives me 9. And times 5 gives me 5. Now I do 9 minus 5 and get 4/15 x. All right, so that's my first part. 4/5, oops, I'll put it over here. 4/15 x. And now I have to get my next constant terms dealt with. So that's 3/4 plus 1/8, which becomes 6/8 plus 1/8, which becomes, that's times 2 and times 2, right? To get to the eighths, that gives us 7/8. Okay, so 4/15 x plus 7/8. There's our answer there. All right, we are moving. All right, I'm going to have to pause there and pick it up in a little bit. All right, so we have another very similar problem. We need to get rid of these parentheses. All right, well, there's nothing to distribute, so we slide a 1 in. Okay, we're going to distribute that to these two terms in here. And 1 times anything, the identity property, stays the same. But if we distribute a negative 1, it changes everything to their opposites. Negative times a negative gives us a positive 1/4 x. And a negative times a negative, or a negative times a minus, is plus 2/3. Now we're going to do our like terms. Okay, we got the 3/8 x plus the 1/4 x. Well, 3/8 x plus 1/4 denominators, 2/8, so that gives us 5/8 x. Now I got my negative 5/6 plus 2/3. Now I immediately know that those are different signs, right? One's a positive, one's a negative. So I'm gonna be subtracting here, but I need like terms first. So times 2 gets me 6. So that's 4. Now, so notice this term is a negative term, this term is a positive term. When we're combining those, we do different signs of subtract, so we get 1/6, and the negative here wins out. All right, so that's negative 1/6, or a loss of 1/6, minus 1/6. Okay, now we're moving on to some other types of problems. GCF means greatest common factor. Remember that C means common? So what goes into 6y that also goes into 9? The highest thing we have is a 3. Okay. Now we did this with downward division. If we put those in a division, we think of numbers that go into both. We say 3, we divide 6 by 3 and get 2y, 9 by 3 and we get 3. And then we ask ourselves again, is there anything that goes into both of those? Do they have any common factors? The 2y and the 3. And when we say no, we realize 3 is our answer. Okay? So now this one is a good one to start. We had some conversations about this in class today with different groups. But you can just think it off the top of your head, like what goes into 16 and 24? 4 does, I don't know, there might be a bigger number. So if I do my downward division, right, oops, and 24m, okay, if I think 4 off the bat, then I divide and I get, okay, 4mn and 6m, and I realize, and then I ask myself again, does anything go into 4 and 6? Well, 2 does. Okay, so then you get 2mn and 3. Now we don't have any other numbers that can go into 2 and 3, right? But they do share a common factor that is a variable. See, they have this factor in common. Factor is just something being multiplied by something else. So yes, we can also pull out that n. Only the one they have in common. See, the n here, this doesn't have an n. So that's not in common, right? And we're looking for the greatest common factors. Okay, so we'll say m, then it's just 2n and 3 left over. So this is our greatest common factor. 4 times 2 is 8. Tack on the m, that's 8m. Okay. Here, this next one, we're looking for a number that goes into these two. The highest thing I can think of is 4. I just test it out. 2xy and 3x. And they both share an x, so I can do the x as well. All right. Now, so what's my answer? My answer's here, 4x. All right, now factoring is using the skills for 21 through 23, but writing out the actual factor pair that can multiply to get you back to the original expression. So it's basically reverse distributive. We're thinking, what number could be distributed into two terms that would equal 5x plus 35? Well, essentially, we just bring the GCF of the two terms, the GCF of 5x and 35, and we divide that out and put it out front. So what goes into 5 and 35? Well, 5 is the greatest common factor. Then we say, okay, well, we can think through. 5 times what would be 5x? Well, we need an x. And 5 times what would be plus 35? Plus 7. Okay? Another way to think about it is you can just do your downward division. And then divide out the 5, right? You get 1x, or just x, plus 7. And there's your problem right there. Okay? That's the number that goes out front. What's left over goes on the bottom. Now this one is one where you're looking at them and you're staring at them and you're thinking, look like they're going to work. So then you realize, oh, if it can't be factored, we write this phrase here, cannot be factored. Okay? Right. So we're just going to write that right there. Okay, let's try 3x minus 12. What goes into 3 and 12? 3. And what would we have to distribute to get it back to be 3x minus 12? Okay, well this would have to be an x, and this would have to be a minus 4. Test it out. 3 times x is 3x. 3 times minus 4 is minus 12. All right, we got one more. Factor that. Okay, we can divide. Looks like 4 goes into both. That would be 4x plus 5 if I divide it by 4. All right, nothing else goes into these two, right? So then we just have 4 times 4x plus 5. All right, now 28 is one where we're first going to simplify, and then we have to write it in factored form. Okay, factored form is using numbers, what we did for numbers 24 through 27. Okay, so we're going to get our answer, then we're going to turn it into factored form. Okay, so first we have to get rid of parentheses by multiplying using the distributive property. So that gets us negative 4x. Now remember, we're doing it to these terms in here. That's a negative times a positive, so that's going to be minus 4. We bring the plus 6x along for the ride. Now we box out our terms, combine the like ones. That's different sign, subtract, keep the sign a little larger, 2x, and down to minus 4. Now, that's the simplified version. Now we have to write it in factored form. Okay, so what goes into 2x and 4? 2. What would be left over if we divided? X minus 2. So our answer is going to be 2 times x minus 2 in factored form. All right, that's one where you just got to read carefully, make sure you don't miss the little details. All right, and moving on. Finally, here we are, last page, and we're ready to rock. We're going to distribute to get rid of parentheses. If there's nothing to distribute, you slide a 1 in. This is a positive 1 being distributed, so identity property. It's not going to change anything. 1 times anything is that number. And after we simplify, we have to make sure that we then put it into factored form. Okay? All right. Whew. Okay, I'm going to show my work down here. So work's going to be down here. We have negative 4/5 times 30x. Okay, that's my first arrow right there. All right, so then I got to make my whole number into an improper fraction. Now I can cross simplify. Common factors I can factor out. So that would be 5 divided by 5 is 1. 30 divided by 5 is 6. I multiply the tops and multiply the bottoms, and I get negative 24. Distribute to there. Okay, that's negative 4/5 times a negative 40 because of the minus, right? So then I put it over 1, cross simplify, and I have a negative 4 times a negative 8, which gives me uh, positive 32. Okay, so this is going to be plus 32. Now I distribute my 1's, it's 42x and plus 4. Combine my like terms. Okay, I have a negative and positive term, so those are different signs, so I subtract, right? And I get 18x. And these two, I'm going to add those up. They're the same sign. Add and get 36. Now I'm ready for factored form. What goes into both of those, 18 and 36? If you said 18, you'd be correct. Oops, wrong way with my parenthesis. There we go. X plus 2. Now, if you don't know exactly what goes into them, you can always do downward division and think, okay, 2 goes into both. 9x plus 18. Now, what goes into those two, though? Oh, I guess 3 goes into both. 3x plus 6. Oh, 3 goes in again. So it would be x plus 2. Ah, okay. That's it. That's all we can do. We multiply those. 2 times 3 is 6, times 3 is 18. So you always have a way. If you can't think of the biggest number, you can break it down into smaller numbers. All right, so here's our answer there. That's in factored form. And finally, we have to get rid of our parentheses. Following PEMDAS, when we simplify, we multiply first. So we're going to multiply here to get rid of those parentheses. I know 1/2 times 3/5 x. Thinking cross simplify, so it just becomes 3/10 x. All right, distribute to that second number, which is a minus 20. So 1/2 times a minus 20. Simplify, and I get negative 10. So that's minus 10. So I have 3. Oops. So I distributed and got rid of the parentheses. I have the 1/5 x still there. I distributed to get plus 3/10 x. And I distributed here to get minus 10. Now I got to combine my like terms. Get those two. All right. I'm adding, so I need my common denominators. 1/5 x plus 3/10 x. 5 and 10 both go into 10. Times 2 to get 10, so times 2 up there. I get 5/10 x. Now, that can simplify down to 1/2 x. So here we go. We're putting these two together. I got 1/2 x, and I still have the minus 10. There's my answer. It doesn't need to be in factored form. Notice this one says put in factored form, but this one does not say that anywhere. So that's my final answer, 1/2 x minus 10. All right, I rushed through it a little bit. My work's not super neat, but hopefully you could follow it, and it helps you prep. So test days can be the best days. Let's go. Put in the work.